scientific notation. This is a way to demonstrate or to shorten very large numbers and very small numbers. So in science and in math, I can be dealing with numbers that are very, very big or very, very small, and they may not be able to be recognizable. In fact, maybe this thing has 23 digits. And if it has 23 digits, that number is so big, it would be hard to even understand what you're looking at. So scientific notation is a way to show the number as small as possible so that it doesn't confuse us and we can maybe get an understanding of how big this number really is. So first off, what you see here, this is what scientific notation looks like. It's going to be 5.1, some decimal, okay, some decimal, and then it's going to always be multiplication. You're going to take that decimal and you're going to be multiplying it times 10. It's always these 10. And then it's going to be to some power. Now, this power right here is 4. So scientific notation is really just a math problem. That's all it is. It's some decimal times 10 to the power 4. So it's set up to be simple and easy to use. So let me show you what it means. Now, if I take 5.1 and I multiply it times 10, what's going to happen is I'm going to make 5.1 bigger. 5.1 is going to become 51, where the decimal is here. If I take 51 and again multiply it by another 10, it's going to make 51 bigger by making it 510, where the decimal here. If I take 510 and I multiply it times 10, it's going to make 510 bigger by going 5,110. I'm sorry, 5,100. So really, every time you multiply by 10, what's happening really is you're making the number bigger by 1 digit. So let's erase this. Now, you don't have to do that because that would be hard. And why would they make something like that that is difficult to use? So look at what happens. If I show you 5.1 times 10 to the power 4, what it really means is I'm going to take 5.1 and I'm going to make it bigger by 4 times, which means I'm going to actually move this decimal 4 places to the right because I'm making the number bigger. These empty spaces are 0. So if I show you 5.1 times 10 to the 4th, it's really 5,100 or 5,100. That's what it equals. So it's an easy way to express a big number. So look at this one. This is 3.009 times 10 to the 7th, which means I'm going to move that decimal 7 places to the right because I'm going to multiply by 10 sevens. So here we go. No, 7 tenths. I'm going to multiply by 7 tenths. So here we go. 1, 2, 3, 4, 5, 6, 7. And that's what happens to this number if you multiply it by 7 tenths. Look how many digits that is. Let's go ahead and change this. Put a comma there. I'll put a comma there. So we're really looking at 3,090,000. Very big number. So if positive exponents do that, then guess what negative exponents are expressing? They're expressing small numbers. So if I give you the 5.1 again, and I say, hey, multiply it by a negative, or actually it's weird, but if I said, hey, divide it by 10 4 times, what's going to happen is I'm actually going to make this number smaller by 4 places. 1, 2, 3, 4, which means I have a 0 here, here, and here. So this one's actually incorrect. It's 0.00051. That's really what you're looking at. Again, remember, negative exponents, remember in the previous lesson, mean that the number is small. Positive exponents mean the number is big. That's really what's going on. It's the same idea. It's just a little simpler way, it's a little faster way to express bigger and smaller numbers. So let me show you how to create scientific notation. Now, when you create scientific notation, let's take this guy as an example. There's only one rule, okay? And the rule is that you're going to move the decimal so that you only show one whole number. So you're going to move this thing. You're going to move this decimal right now in this digit, in this number, this decimal right back here. We want to move it in this direction, but we want to stop once we're showing one whole number. And that means I'm going to have to stop at 1, 2, 3, 4, 5, 6, 7. I have to stop here because this 5 is going to be my whole number. So that's the rule about setting up scientific notation. So let's create this. Remember, it's some decimal. Now, I want to use the number 5.055. Now, the whole idea is that you drop these zeros. That's the whole idea. So I will not express any other zeros after that final 5. Okay. Now, again, remember, you're multiplying by 10. And then it's going to be 10 to the power of what? Well, that was the number of moves that it took that decimal to get between the 5 and the 0. And that was actually a positive 7 moves to get there. Remember, this is a big number. I'm trying to express it as small or a little smaller. So because it's big, it's a positive exponent. Look at this guy. This one. Well, this is a very small number. I want to express in scientific notation. So I want to get that decimal and I want to move it in the opposite direction. But remember, I want to stop once I'm showing only one whole number. That means I have to stop between the 6 and the 7 because this would be one whole number showing, which is to the left of the decimal. So let's see. How many times did I move? 1, 2, 3, 4, 5, 6, 7. 7 times again. So my decimal that I create is 6.78. And remember, it's times 10, always. Now, to what exponent? Well, it was 7. But remember, this is a small number. So the exponent is actually a negative 7.